Imagine an online portal for whistleblowers to submit information about harbor crime like drug smuggling. And it shows the authorities an empty inbox. No messages. No crime. This happened in Germany, Bremen. And witnesses tried to use the system for several years, but their messages were never read due to a misconfigured subsystem. And until a defendant mentioned this in court. And this is the perfect entry to my talk, because monitoring on application level is not a nice to have. It's essential. Because applications which look nice on the surface can fail silently. So welcome to my talk. A talk about a Checkmk customer, LGB, which uses synthetic monitoring to keep their applications available and functioning. So what is LGB? In one slide, LGB is the official geospatial data provider in the state of Brandenburg, Germany. And they are providing a wide range of services, over 500, to customers like administration, business, and the public. And I'm very happy that Carsten Schöki from the LGB is here with us today. Give him a big round of applause. Welcome, Carsten.
Hello.
Carsten, kannst du in ein paar Sätzen eure Monitoring-Landschaft beschreiben? Can you briefly explain your monitoring landscape in a few words?
Ja, gerne. Wir sind Checkmk-Kunde schon seit vielen, vielen Jahren, so als Anfangszeiten, so ich glaube 2010. Nutzen seitdem intensiv in unseren beiden Rechenzentren Frankfurt-Oder und Berlin im Land Brandenburg die Checkmk. Haben Staging-basiert zwei Umgebungen, einmal für Test und einmal für Produktion. Immer eine zentrale Wartungszeit und 3 Satelliten hinten dran, die Checks ausführen. Haben in der Produktionszeit ungefähr 1000 Servern oder Netzwerkknoten, die wir überwachen mit so ungefähr 50.000 Services. Und zusätzlich seit 2 Jahren 30 End-to-End Synthetic Monitoring Checks.
So, many years ago they migrated from Nagios to Checkmk. And they're running 2 data centers in Frankfurt and Berlin with 2 environments, each with a central site and 3 satellite sites. They're running over 50,000 services and plus around 30 Robotmk services. Carsten, second question. Zweite Frage. Wie sah es bei euch vor der Einführung von Synthetic Monitoring aus? How did things look like before you introduced Synthetic Monitoring?
Wir haben natürlich auch schon sehr, sehr viel probiert, weil wir ja sehr lange im Monitoring unterwegs sind. Von Sakuli, Webinject, Auto-IT, wie die ganzen Tools so alle hießen, haben wir sehr viel ausprobiert. Leider sind wir immer wieder an der Komplexität gescheitert, speziell in der Integration in Checkmk. Wie wird es angezeigt, was hat die Fachabteilung daraus zu entnehmen, wenn ein Fehler da ist, und die Komplexität war leider für uns zu hoch und das Aufwand-Nutzen-Verhältnis war einfach nicht mehr gegeben, dass wir dann eigentlich immer wieder aufgegeben haben, bis Robotmk kam.
So they always had the need to monitor their portals and viewers from an end-user perspective. They tried different tools like Webinject and Sakuli, but it was in the end always too much tinkering and too much effort to maintain this all, and the integration in Checkmk was always very poor. Dritte, letzte Frage, Carsten, warum habt ihr euch dann für Synthetic Monitoring entschieden? Why did you finally decide for Checkmk Synthetic Monitoring?
Also primär die angemängelte Integration in Checkmk, MKP installiert, regelbasiert, das jeder kennt, regelbasiert eingestellt und letztendlich, wenn man sich ein bisschen auskennt mit den Robot-Skripten, geht das relativ schnell an den Start. Der zweite Hauptgrund war Robot Framework an sich, ist Open Source, sehr lange am Markt und dadurch, um Vendor-Logs so ein bisschen zu vermeiden, haben wir uns für Robot Framework und diese Implementierung entschieden. Und zu guter Letzt, was ich auch immer an den anderen Tools immer ein bisschen bemängelt habe, Diese Sichtbarkeit in Checkmk, also wenn ein Fehler auftritt, wie kann der End-User, also der Fachdministrator sehen, wo ist der Fehler, wie kann ich es reproduzieren und wie weiß ich, was letztendlich zum Ausfall führte. Und diese Logfiles und auch diese Screenshots, die da letztendlich jetzt drin sind, die sind einfach genial.
So Carsten mentions 3 reasons. The first reason is the rule-based approach from Checkmk, which is also used to configure Robotmk. This is a toolset everyone in the team knows already. Then Robot Framework as an open source tool prevents you from a vendor login, and it keeps you flexible and to use different technologies. It's not fixed to a technology. And lastly, the integration, the visibility of logs, of runtimes, and also the embedded screenshots is what they really appreciate. Carsten, vielen Dank, dass du hier bist und vielen Dank auch, dass wir dieses tolle Kundenprojekt heute in der Öffentlichkeit zeigen dürfen. Many thanks to you and the LGB for your willingness to be available. Thank you very much. So, with LGB as a customer example, I want to give you now answers to 3 questions I'm often getting from customers in trainings and so on, and I want to step directly into the first one, the big why. Why synthetic monitoring with Robot Framework? Robot Framework, this open source tool, is, let's say, the hidden hero in this whole story because it's very flexible, and Robotmk is, let's say, only the glue between these great tools, Checkmk and Robot Framework. And you will see now in the first example how Robot Framework is used to test an application called DaCapo. In DaCapo, users can get information about the cadastral system of Brandenburg, and it's always needed for property sales, taxation, building permits, and so on. So let's go and let our robot run. The robot opens the portal, goes to ordering. Now it logs in with a so-called Bund ID, a special kind of authentication for all citizens in Germany. After that, it selects to get an information about a certain parcel of land. It enters the exact address of the parcel. And after that, it clicks on search. And when the result is loaded, the test closes. And what you see now is Visual Studio Code opening automatically the log file, the HTML log from Robot Framework, and you can now expand all the nodes, all the keywords which were executed with their runtime and status. If we look again on the log file, you will see that it's super easy to read, but you will have the question in mind, where does Robot Framework know what it has to execute? And this is hidden in the keywords. The keywords can be nested inside other keywords. And I want to explain you my approach, how I organize the keywords in my customer projects to keep the code very maintainable. I always use 3 levels. On the lowest level, I group the atomic technical keywords into sequences which I call the application keywords. And even if this looks a little bit technical, it hides away all the complexity of Python code which is running behind the curtain, right? And this is the great thing about Robot Framework. You are using the whole automation power of Python without writing any Python code, right? Then I organize multiple of these application keywords into larger coherent steps, which I call the logical step keywords. And you can already see how the readability increases. We have only human-readable keywords with arguments. And these logical step keywords are then my building blocks to create the test cases. So as a conclusion, we can say the keyword-driven syntax makes it possible to write technical code in a way that it becomes readable just like a user story. Another thing, if you want to click on a button, you expect the application to react immediately, right? But modern web applications oftentimes are loading data asynchronously from APIs. When the robot in DaCapo clicks on search, I don't know when the map has finished loading, but I know when the browser has finished loading the data from the API. Robot Framework, or better, the browser library, based on Playwright, provides a so-called promise. Think of a promise like a kind of parallel side track you can use to wait for a certain condition. And this makes it possible to continue the test only when the data from the API have been loaded. I can highly recommend this browser library based on Playwright instead of using Selenium. It's very flexible and even with modern web applications, very, very powerful. At the Synthetic Monitoring Knowledge Fair stand, I have created a demo video which checks the Checkmk chatbot using exactly this method. Next insight, I want to show you how the Visual Studio Code Editor can greatly support you in your daily work with Robot Framework. At the LGB, for example, there are a number of applications which are all based on the same core application, the viewer application. And it's required to execute a number of tests on all these dedicated deployments. For example, searching a city, printing a map, planning a route, and so on. And you probably don't want to write now a total of 14 test suites because this would mean a lot of redundant and unmaintainable code. The solution is obvious. We are passing the viewer name, the viewer type, and the environment as variables to the Robot Framework code, and all the rest of the configuration is then loaded from a configuration, a YAML file. And this is where the robot code extension for Visual Studio Code is a great help. This extension allows you to create so-called profiles, which combine all these different parameter combinations for Robot Framework. And with these profiles, you can execute then your test cases. The next video shows you how I use these profiles to run a test in Visual Studio Code. There are different ways. I can either run the complete suite, the collection of tests with these profiles, but I can also selectively run or debug a certain test. And here I'm executing the test Straßennetz, road map in production. The aim of this test is to verify the functionality of the route planning feature. And after entering the start and destination, the test verifies that at the bottom of the page, there is an elevation profile shown, which is then the proof that the route has been planned. So far, I have shown the execution from Visual Studio Code. Robotmk, of course, or the scheduler of Robotmk, runs all these tests on dedicated Windows machines, headless in the background. And for their configuration, you don't have to touch these Windows machines. This is completely done in the bakery rule in Checkmk, where you enter the configuration data. And we see again, we are entering the environment and the viewer type as variables, which are then passed to Robot Framework as parameters. No need to touch the test client. And finally, insight number 3, I want to give you 2 examples for a great integration of Robot Framework into LGB. First, we have the feature managed robots, and I would highly recommend it to deploy your Robot Framework files to the test client. But if you have a lot of updates to your test code, this can put too much strain on the bakery. At LGB, they decided to use GitLab and GitLab runners. Whenever a developer pushes a commit to GitLab, the runner then pulls the newest commits from the GitLab server and then synchronizes the downloaded commits with the local base directory of Robotmk. And in that way, the commits are getting nearly in real time on the test machine. The second example shows you how versatile Robot Framework is. At the LGB, there are 2 applications maintained and developed by an external service provider. And whenever there is a new release, the guys at LGB have to run acceptance tests to verify that this new version is still working as expected. And also these acceptance tests are based on Robot Framework. And I couldn't explain the advantages any better than Marvin Coles, application admin at LGB, who says, the big win for us is that the same robot scripts work for both acceptance testing and synthetic monitoring, and everyone can read and understand them. Finally, I want to give you a little tour through the monitoring dashboard, the synthetic monitoring dashboard at LGB. In the top left corner, you see some statistic data, number of test nodes, number of pass tests. Right of that, there is only one scheduler running currently in production. Here we have a table of all the scheduled plans, what the schedule executes. We have multiple instances of the viewer, and we have a variant field to make them unique. Then we have a table with the 5 longest test run times. Below of that, a graph with all the test run times. Right of that, all the test cases. And here we actually have a failed test. To inspect the log file, I click on the blue icon, which then opens the HTML log file of Robot Framework directly inside of Checkmk. And here we see a screenshot of the failed application embedded into the HTML log file, which makes it very easy to see where the error really occurred. So this was a brief and a very fast insight into LGB's monitoring landscape with Robotmk. And I want to close this with a quote from Carsten Schöcke, which he once sent me via email. The strength of synthetic monitoring is to show whether the whole system is working together. The whole band has to play, and no musician must drop out. And I like that very much, because sometimes it takes a while to notice when an instrument drops out. But when the solo part comes, it's impossible to ignore the silence. So synthetic monitoring is not a nice to have, as you have probably seen. It's essential, because systems which look nicely on the surface can fail silently. Thank you very much.